So I think the last time I had actually introduced you to the course on your microprocessor for this semester, and as I told you, this is not NOT. This is not a prerequisite for your VLSI courses, but a part of it. So prerequisite for VLSI courses would maybe in your next class or your next semester or something like that. And as you already see, I think some of you may have also attended a workshop which was how to make electronics, India into an electronics manufacturing hub. So that was on the manufacturing side of it. In the design or in terms of the architecture or in terms of different types of embedded systems that you see all around the globe, they have this microprocessor as a primary part of the overall electronic system. So what I mean is the heart of any electronic system that you take, the microprocessor is the heart and one cannot do anything without it. So now let's just go to the timeline about on this microprocessor per se. So when did it all start? It all started with the invention of your transistor. And anybody know who all got the Nobel Prize for this? Hello?
No, sir.
No, sir.
Yeah. So, you know, as the time is progressing, you are seeing the whole IT industry, the whole Silicon Valley that has come up is basically because of this major invention, which was transistor. So transistor is the brick for your whole building. As in, transistor is the building block for the complete IT industry. Had there been no transistors, there would have been no ICs. And if had there been no ICs, what is an IC? IC is an integrated circuits. And had there been no ICs, you would not have had different components, which includes microprocessor, memories, and different types of or different forms of combinational and sequential circuits. As I could understand, you people have already been taught courses on digital logic or digital electronics as well as analog electronics. So in both these cases, the base or the building block again remains the transistor. So I would just like to, tell you a bit more in terms of transistor, because it is according to these transistors that the whole uh, evolution of the microprocessor has happened. So the transistor initially was invented by and people got Nobel Prize way back in the way back for their work in the 40s and 50s. And initially the transistor was a BJT. BJT is like bipolar junction transistor. So from BJT, as the time progressed, because of various advantages and to mitigate the disadvantages of the BJT, the introduction of silicon-based MOS transistor came into being. So initially there were a lot of work that was happening in the US, particularly in Fairchild Semiconductor, and finally it was that Gordon Moore came with a very famous law way back around mid of 1960s, which is famously known as the Moore's law. The Moore's law stated that the transistor density on the integrated circuits doubles after about every 2 years. So this is the basic principle which has been there in the evolution of the IT industry, and in particular in the microprocessor industry. So Gordon Moore also was one of the co-founders of the microprocessor, and that was very much essential because what did microprocessor, why do we call it the heart of the electronic system, is essentially because of the very nature and very reason that it performs all kind of arithmetic, logic, and different types of execution. So in the 1970s, after we had ICs coming into these worlds, which is like integrated circuits. So what was an integrated circuit? It was you were using all kind of active, which is your transistor, and passive devices, and making different forms of your combinational or sequential circuits. So in the early 1970s, your first microprocessor has come into being, and this microprocessor was famously known as your 4004 microprocessor. Please note down 4004 microprocessor. So this was developed by Intel in the year 1971. Its maximum clock was 740 kilohertz. Its word size was 4 bits. We will be defining what do you mean by this word size just after I finish talking about the configuration of your first microprocessor that came into being. And it all started in the Intel foundry that was there in the US. The process technology, or what you famously call as the technology node, was of 10 micrometer. So in that chip, there were around 2250 transistors. That is 2250 transistors. This may not be this number may not be very rigid, but around this number, around 2250 to 2500. And the technology that was used was a MOS technology. So essentially a PMOS technology. So that is why you need to do some prerequisite to understand what is this technology all about. So in short, what is PMOS technology? So let's expand. What is MOS? Please, anybody?
Metal oxide semiconductor.
Yeah, good. And what is PEM? So it is a metal oxide semiconductor sort of transistor that was used. So PMOS technology or PMOS type of MOSFET is when you have P type of MOS transistor. Okay, and when we talk about process technology or the technology is 10 micrometer, anybody knows what exactly that we are talking about?
So channel width.
Yeah, so we are talking in terms of the channel length. Exactly.
Yeah, sorry, the
So
channel length.
yeah, so it is the length or the size between your source and the drain. So you can see 10 micron was when it all started, and the frequency or the maximum clock. So how is frequency related to your clock or your time? Anybody?
Sir, is it the point till which the microprocessor is in optimum performance?
Somebody here other than you? Yeah. Anybody? What do you mean by when we say, yeah, class? Okay, I will just, I'm not very sure how many of you are available here and listening to me. So I will just start naming you. Premlata, anybody? Premlata, can you answer on this or can you comment on this? Are you there? Manali?
Yes, sir.
Yeah. So you've just joined?
Yes, sir. Because here network issue. That's
Okay,
the
no,
reason.
no issues. Manas Agarwal?
Yes, sir.
Yeah, I posed a question.
Sir, this
Would you
clock,
like to comment on that?
sir, I don't know about this clock speed. So,
Arvind,
Yes, sir.
do you have any idea
Yeah.
what do you mean when we are talking about clock speed and stuff like of how
No,
is
sir.
frequency related to your time? Okay, very basic. How is frequency related to your time? Anybody?
1 upon
Inversely proportional.
inversely proportional.
Inversely relation to what?
Uh, Time is inversely has inversely proportional relationship to frequency. 1 by time period is basically frequency. 1 upon time.
Nice, nice, nice. So the first microprocessor we are talking about, we say it has a clock size or frequency. So what was the clock speed? Maximum clock speed that I said?
740.
The
Yes,
number of revolution.
740
Cycles per
kilohertz.
second.
Yes, 740.
The cycles per second.
So can you just convert, all of you, can you just convert what is the time period that we are talking about? All of you.
Sir, 1 microsecond.
1 microsecond. Are you sure? How
1
did you how did you calculate?
Sir, can you repeat? Sir, can you repeat
1
what are
upon
you
740
asking to
kilohertz.
calculate?
So Actually, we started with the timeline of microprocessor. So we started when it came into origin and was developed by Intel. How many of you have heard about Intel? I guess all of you.
Yes,
Hello.
sir.
I guess most of you must have heard about a company by the name of Intel, since you
Yes,
are
sir.
using some kind of digital platform like your laptops and stuff like that.
Yes, sir.
So don't you see there is an Intel written on your laptop or your desktop?
Yes, sir. Yes, sir.
Intel inside,
Yes, sir.
the same company that we are referring to. So they came with the first microprocessor, and Gordon Moore was one of the co-founders, and he came up with this famous law that every 2 years or 18 months, the number of transistors per unit area gets doubled. So that also, in fact, affected in terms of power, in terms of your clock frequency, and in terms of transistor density, which was directly related to the memory, size of your memory. So the first microprocessor that was developed by Intel around the globe or across the globe was Intel 4004. Its maximum clock was 740 kilohertz. So you already know the relation between clock frequency and time period. So in terms of time, and I'm talking about 740 kilohertz, what is the time period that we are talking about? Yes, all of you please calculate. Are you there?
Sir, around 1 microsecond.
Is it around 1 microsecond? Okay, so
Sorry.
I think it's 8 microseconds, no?
so how did you do it? 1 divided by?
Kilohertz. 740 kilo.
Okay, so 1 divided by 740 is what?
It's around 1.35 into 10 to the power minus 6 seconds.
Okay.
Yes, sir.
Okay. So it is around 1.35 microseconds. That is what we are actually talking about. So that kind of speed or that kind of frequency clock was present in your first microprocessor that came into origin, and that was by Intel. And the technology that they used was a PMOS transistor having a channel length of around how much? 10 micrometer. So as we talk that we are using microprocessor all across, right from your laptop to desktop. I just give you a simple task just to make you more familiarized with what is actually happening. So can you identify with the microprocessor that is there in your laptop or a desktop which you are presently using, or your smartphones which you are presently using? What is the frequency that we are talking about? Please, all of you, try to figure out the frequency.
Sir, my laptop is 2.4 gigahertz.
No. Just all of you do that. All of you do that, and then try to find out what is the time period we are talking presently. All of you.
The 4 nanoseconds.
Aditya? Aditya, are you there? Aditya, are you there? So he is not there.
Yes.
Okay, I'm not talking about Aditya Sai Kamal. Aditya Meena, are you there?
Yes, sir. Yes, sir.
Okay, so have you calculated?
Sir, I'm looking for specifications of my laptop particularly.
Yeah. All of you can take few minutes, get familiarized, so that you know the difference when it all started way back in the early 1970s and presently. So those of you who have already checked out on your laptop can look at the configuration of the microprocessor that is used in your smartphone or a laptop or a desktop and stuff like that. Just see the present frequency on which your microprocessor is embedded into your electronic device or electronic system.
Okay, sir.
All of you, please try to do that. As somebody mentioned, when it all started, it was around 1.35 or around 1 to 2 microseconds. And the number of transistors that was used in your first microprocessor was just around 2300 transistors, and it used the PMOS technology. Sai, do you have the answer? Sai Vikas?
Sir, I'm looking it up.
Sir, it's around 500 nanoseconds.
500 nanoseconds? No.
Sir,
Yes, sir.
4.17 nanoseconds.
What is your frequency, Badal?
My
0.5
frequency.
nanoseconds.
Just Badal.
Wait.
Approx.
Okay.
0.5 nanoseconds.
It's my mistake. It's 5 nanoseconds.
0.5. 0.41 nanoseconds.
Hang on. Please. Only those whom I'm asking questions should switch on their microphones. Rest. Yeah, Badal, you were.
Sir, it's like time period you want to know?
I don't want to know. You should be knowing.
Okay, it's 0.5 nanoseconds.
So how did you get? What is the frequency?
Around 1.8 gigahertz.
1.8 gigahertz. So you have a laptop or a desktop?
I have a laptop.
Okay, and it has Intel.
Yes, sir.
Yeah. So remember, there are different types of microprocessor which exist. We have already talked about that. So you may have a ARM microprocessor, you may have AMD microprocessor, you may have Intel microprocessor. But it all started with Intel, and it's still Intel has a very big market in a particular type of architecture. So as we will be building up in terms of microprocessor, we will be talking about the evolution of the microprocessor that came out from Intel, and it had a very particular architecture which is still followed till date. So which is generally called as your x86 microprocessor. Okay, so we will be building up only
So
on
what
this.
could you repeat the last part about the 86 microprocessor?
So it follows a particular type of architecture. So I think I really do not know whether you have done a course on microprocessor architecture, but as the time as the evolution of microprocessor happened, it was generally bifurcated into 2 or 3 major domains in terms of its architecture, and that was regulated according to the requirements. So what was the basic requirement? The basic requirement, because of which you see a different architecture of your microprocessor, is due to the very reason that the power needs are different and the processing power needs are different. So like the processor that you use in, say, a smartphone or a tablet is not the same as in terms of its architecture, is not the same as the processor that you're using in your desktop and servers, and probably even in your laptops.
Right. Okay.
So the ARM architecture that you're using in a lot of these smartphones and related devices is different, not only different type of its architecture, but also in terms of different in terms of operating system. So the moment you talk about all these big tech companies, whether you talk of Apple, it has a huge market capitalization. So that's Apple produces both desktop, laptop, as well as smartphones. Okay. Similarly, when you're talking about the Android base, so it has a operating system which is not necessarily the same as what you use in a desktop or in a laptop. Similarly, when you're talking about any of the companies, you may have HP or Lenovo or different types of desktop or a laptop. The operating system that you're using and the processor architecture that you're using is not the same as you may use in your smartphones, any of the Android, any of the smartphone. So most of the smartphones are Android-based smartphone, and that follow a different. That is based on the architecture in that particular smartphone, which is not the same as the operating system that you use in your laptop and desktop. So when you're using your laptop and desktop, the operating system is according to the architecture in your microprocessor, and that operating system is generally Windows. That operating, please can you switch off the order? Yeah, that operating system is most of the times Microsoft based. And the other operating system that you're predominantly using in your smartphone having a different architecture is using operating system, which I think a lot of you must be familiar with. That is Android based, and you already know Microsoft as a company does an operating system for your desktops and laptops, while Google is doing it for your Android. So this was just giving you an overall picture. Now coming back to the basics, very basics. All of you have calculated Badal,
Yes, sir.
all of you have calculated what was the frequency of operation?
Of my laptop,
Yeah,
it was 1.8 gigahertz.
1.8 gigahertz. So how, in terms of T, how much time period? So that was the frequency of operation or your clock speed, right?
Yes, sir.
I hope all of you must have calculated it. Is simple. 1 by frequency gives you the T. So I hope all of you have calculated. And the process technology we have already talked about. Now we also talk in terms of the word size. So the first microprocessor, which was 4004, the word size was 4 bits. So we shall be defining are you there? Is anybody there?
Yes, sir.
Yes,
Sir,
sir.
your audio is glitching. Sir, your audio is glitching.
Yeah, come with that again. You said something. Yeah, all of a sudden when I see, I hear no noise, it appears as if I've been like disconnected. So please note down the basic definition of your microprocessor. So in your microprocessor is a kind of a silicon based chip which has the ALU, which is the arithmetic and logic units, the different register circuits, and the control circuits. So as time progressed, this microprocessor had a different type of variation, and we shall not be me and Dr. Poonam would not be talking on the microcontroller part, which is I think a bit beyond this course. So a microcontroller is essentially a silicon chip which includes a microprocessor, a memory, and an input-output device in a single package. So please note down some of the basic definitions that you would be using and should be familiar in the course of this. So one needs to define what is an instruction. Please note down the microprocessor can perform different sets of operations on the data it receives depending on the sequence of instructions supplied in the given program. So each type of microprocessor is designed to execute certain set of specific operation, and these group of operation is called your instruction set. So to begin with, it all started with 4-bit microprocessor. So what is bit? Anybody? Class?
Yes, sir.
Sir, I think it stands for binary digit.
I cannot understand what. Yes?
Sir, I think bit stands for binary digit.
So it's like basic unit of information type.
What is actually happening? Actually, we are dealing with a machine, and machine only understands anything that is machine as in electronic device which only understands zeros and ones. Okay, so that is why we call it, it is having a binary format. So it all started with the strength or the length of number of bits. So a group of 4 bits is what you call as the nibble. Please note down, a group of 4 bits is what you call as nibble. So machine only understands binary. What is binary actually means? Whether it is in the high or low state. High basically is represented by 1 and low is represented by 0. So the machine only understands ones and zeros. It doesn't understand anything other than that. So everything that you want your machine to understand, to perform, or to execute would only happen in terms of zeros and one. So a group of 4 bits is what you call as nibble. A group of 8 bits is referred as a half word or a byte. while a group of 16-bit is referred to as a one word. And a group of 32 bits is referred to as a long word. So it all started with 4-bit, and nowadays all the processors that we are using, it shall be either of 32 bits, 64 bits, or 128 bits, and so on. What does that mean? That all these processors can manipulate or can perform different types of arithmetic and logical operations having a strength of 32 bits onwards at a time. Depending upon how to mitigate the power requirements or power problems, how much one can push into the frequency of operation of these microprocessors. So now we shall not be talking about all the other companies. I mean, like there were parallel many companies like Motorola or Fairchild or even IBM. They come with their own types of microprocessor, but at this moment of time and as the time evolved, only few of them have survived, namely the AMDs, the Intels, and the ARMs of the world. And for specific application, you may also see if you are using a laptop or a desktop, you may be having NVIDIA. Again, that is for your graphics, and similarly you would also have Qualcomm, which is used in all your 5G technologies and other kind of communication devices, including your smartphones. So they are basically designing all these related things which contain the functionality of a microprocessor. Remember, microprocessor is the heart which basically performs all types of different arithmetic, logical, and other different types of operation according to the instruction sets that you give by writing a program, say. And it all started from here. So since we will be talking predominantly on 8085 microprocessor, we shall also be talking about the various instruction sets, because that is what is required for you to perform various types of operations. And this was basically done in a low-level languages. So what is a low-level language and what are the other languages that we talk about? The low-level language is what the machine understands directly. So the low-level language that we shall be talking is your assembly language, and the rest of the languages are not exactly, is not a low-level language, but what you call is the high-level languages. So high-level languages have these compilers which convert them from high level to low level, and finally everything is being understood and executed by your machine, which is actually an electronic gadget, whether in digital form or in analog form. but when we are talking of microprocessor, we are just focusing on the digital form. It would only understand anything and everything in terms of zeros and ones. So zeros and ones basically needs to be translated at the end of the day. So zeros and ones are basically done in its equivalent form in your assembly language, or also what you call as the machine language. So we will be talking in detail about this assembly language so that you are able to execute different types of your instructions, and your microprocessor is able to understand and execute your instructions that you are giving to your processors. So 8085 was also not only popular, but it became very popular even in the academic circles, so as to understand the evolution of microprocessor, as well as to understand the assembly language and how to execute various types of instruction which you as a programmer or an external source would define your microprocessor to execute various commands. Okay, so what are the major operations that your microprocessor would perform? So every microprocessor that you talk about would be performing two major operations. The first one being the arithmetic operations. So it is not necessary that all of them would be performing the same. There are some application based microprocessors, and so microprocessor range from a very particular application based to a generic, a general purpose microprocessor. So here, when we are talking about 8085 or its next version, which is 8086, we would be talking of a general purpose microprocessor. And we would also see what happened, what was the internal architecture of this popular 8085 microprocessor, and how did the scientists and engineers at that time try to make it better and improve it to a form which was 8086 microprocessor. So the evolution in a way. So 8085 microprocessor, the type of arithmetic operation that it performed was add, subtract, and so on. While in terms of logical operation that it performed included digital operations like AND, OR, XOR, shift left or right, etc. So in a microprocessor, you essentially, a microprocessor based system, it essentially constitutes of four components. One is your input devices, where you kind of, as an external user or a programmer, you would be giving certain set of instruction. You would have a microprocessor which would have the control unit, the ALU. Then the third component would be an external memory, which is basically a kind of RAM, which is your random access memory. And After that, finally you will have output devices. So anybody who would like to talk about all these input devices which you must have used, whenever you may have used a desktop, what are these input devices and output devices? Anybody?
Sir, mouse and keyboard are input devices.
Right.
And there's stuff like speakers and the monitor, which are output devices.
Correct. And how about these memories? So I just give you some overview. The memories essentially can be bifurcated into two. One is the transistor based RAM memories, even ROM memories, but predominantly RAM memories, and they are further bifurcated into your DRAMs and SRAMs, which is dynamic and static RAMs, while you have another memory which is what is known as your hard disk. So hard disk is made up of these magnetic materials, and according to the storage that is defined in different sectors of these disks, the outputs and the inputs, including various instructions, are stored. While in the RAM, whenever you switch it on, it will be having and enhancing your microprocessor memory, which also constitutes of your registers, as well as temporary memory storage to perform various types of arithmetic and logical operations. So remember, in the mid and late 1970s, when 8085 came into picture, that was something latest at that time. So probably at our parents or grandparent times, this was the best thing that was offered to the world by companies which included Intel, IBM, Motorola, etc. So that was the latest technology. At that time, there was no operating system. Remember, the operating system also evolved with time. There was no compiler, there was no operating system per se. There was a direct link between your machine and you, and the only thing that you, as a programmer or as a user, could do was writing long codes for your microprocessor to execute those commands and come out with solution. So initially it all started with your like 400. The first major market was to use them in calculators. Okay. So now that we know about this, we know that your microprocessor essentially constitutes of three major things. The first one is your ALU, which is your arithmetic and logic unit. The second part of this microprocessor is the control unit. The control unit. And the third part of the microprocessor and executes the instruction. So these three So the microprocessor fetches, decodes, and executes the instruction, and these three are happens in a cyclic form. So this sequence of fetching, decoding, and executing continues until all the instructions are performed that is given by the end user. So before that, before in the fetching part, it needs to read which instruction it needs to perform and from which data it needs to manipulate or perform any type of arithmetic or logical operation. So once the execution is done, then it is either stored in your register or in your RAM or in your external hard disk or your input-output devices. It can be displayed on the screen or it can be printed out using a printer. So before we progress, I would like to define few more things, but I would also like you to tell me how many of you know what is a register. You must have done courses on the sequential and combination circuits. How many of you know what is a register? Rajesh? Rajesh Kumar? Rajesh Kumar? Sai Vikas?
Sir, it is basically memory.
Carry on.
It is basically, sir, I think it is memory on which operations can be executed.
So what different types of registers you have studied in your previous classes?
I don't have much idea.
Oh, you've never taken any course?
Yes, sir, but
Manas? Manas?
We have memory address register, memory buffer registers.
What are you talking?
So
what are the different types of register that you have studied before?
Sir, series register, like series input, series output, parallel register.
Badal, can you elaborate and be more precise? You are not completely correct. Yeah, I'm talking in terms of what are the different types of registers that you have studied in your previous classes. So this is like your previous knowledge that needs to be required. I mean, like that's why you have courses before, so that it becomes a building block for the next.
Sir, we haven't studied architecture in particular, so we don't really know
No,
what different registers.
It's not in terms of architecture. We're not. There's no architecture per se when you're talking about a simple register.
Sir, shift register.
Okay, so you're coming with the serial input, serial, then shift. What are these? I mean, like, so what all have you studied? I mean, like, it all depends on what all you've been exposed to.
Actually, shifting of.
Have you heard about serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out?
Yes, sir.
Yes.
So when did you hear it? I mean, like you have to use all those things at your later stage, say in microprocessor. The moment you start to develop on all these things, you need to know very basics of all these things. What else did you learn? So is it a sequential circuit? It is made of a sequential circuit or combinational? What is the difference between, say, latch and a flip-flop? Are they memory elements?
Sir, latch is governed by a clock, and flip-flop aren't. No, sorry, flip-flop is governed by the by a clock, and latch isn't governed by the clock. Like we don't have to apply clock at the input side
Are you
for.
sure? Check it. What is the difference between edge triggered and level triggered? Does it,
Sir, edge trigger, level triggered are the.
in terms of latch and flip-flops? I'm just giving you a hint. Is there a difference?
Basically, sir, memory. Memory, sir. Previous input and past input.
When did you do this course on digital logic or digital electronics? Have you done a course on this or not?
So last to last semester.
Okay, so I would advise you all to go through that material, especially on combinational circuits, sequential circuits, and so on, because that is the building block for all the courses, including if you going into the domain of architecture or in terms of VLSI design or in terms of microprocessor or in terms of any embedded, in terms of that is like a prerequisite. So one is through transistor, one is through digital block, and one is through analog circuits. It's as simple as that. You cannot do away, because moment you're talking about all these processors, they are already using all these digital and analog block, like your T55 timers and so basically based on analog circuits, and your digital blocks based on your combinational and sequential circuits. What is a combinational circuit? Anybody? What is a combinational circuit?
Sir, which basically depends on the input.
Combinational circuit is one which depends on input. Can you elaborate? There's no matlab.
Sir, in sequential, we can.
What is a combinational?
In sequential, we can talk about previous input and past input, just like memory. And there is no memory in combinational circuits.
Sir, combinational circuits outputs aren't affected by the previous outputs.
Let me be very frank. I mean, like, if you do not complete, if you just give some some words which is a part and parcel of the overall understanding of the definition of combinational circuits, it makes no sense. When you're doing all these things, you're doing with a you're building, you would be finally doing a master's in your subject. So master's is like an MTech is it's already a master's degree in engineering. So you should be knowing inside out. Otherwise, how will you just do all these things? And I mean, by the way you are answering, it's partially correct, partially incorrect, partially complete, partially incomplete, and it doesn't give a very concrete answer to a simple question like what exactly is a combinational circuit. Yes, anybody else? You can also read it right now from your books, from internet. Try to understand. If you don't remember, doesn't matter. Nowadays everything is online, and our class is also online. If you kind of cannot recall or cannot understand, you can just try to do it right away. But if you kind of neglect it for present or future, it doesn't help the cause. It's as simple as that. Just read it, understand it, and then speak. Yes, Ishan, you just joined, right?
No, sir, I rejoined. I was having some trouble with the audio.
Yeah, no issues, no issues. What is? Can you answer? Remember,
Sir, what was the question?
What exactly is a combination circuit? And then how do you differentiate between a combination circuit and a sequential circuit? These are the building blocks for your all, electronic systems. For your registers, or your counters, or your this things, it's all there.
The sequential circuits are simply circuits
Combination circuits. That was my question. Anyways, I think you should.
So combination circuits are based on Boolean logic. The circuits that are based on Boolean logic, that carry out the Boolean logic.
What does that mean? I mean, like everything. Why do you use Boolean logic?
To carry out arithmetic operations normally, or statements of sorts.
Remember, your microprocessor per se only understands 0 and 1. Okay, so if you have any type of circuits, you would like to reduce that circuits which has the same output but lesser number of devices or inputs that you're using to get the same output. Boolean expression or Boolean algebra generally is a method to reduce the number of these internal components that are used to get the same output and number of inputs. How would that help? If you're using lesser number of say gates,
so
like
it would require lesser number of components.
Lesser number of components means lesser number of transistors. Okay, so moment you are talking about all these logical operation or arithmetic operation in either SOP form or POS form, at the end of the day you would want minimum number of gates, so minimum number of transistors, minimum number of inputs to get the same output. So if one scheme of thing has say 20 gates and the other is having 8 gates, which one would you prefer? And giving you the same output, say.
So the 8 gates one, it's more cost efficient.
As simple as that. And Boolean expression actually helps you to kind of sort out these things. Why are you? So what has that got to do with talking about your sequential circuits or combinational circuits? What exactly is combinational circuit? Please read right now.
Sir, it is a memoryless logic circuit.
Please read the basic definition, try to understand. I'm not getting the right answer or remotely close answer. We will be always talking of output with respect to input.
Sir, in combinational circuit,
memory and timing, I think you're not very clear of what you're talking about.
Sir, in combinational circuit, the output which comes does not depend on the previous outputs, but in sequential circuit, the output which is coming may depend on the previous outputs. In combination circuit, it only depends on input.
Now
But
you're getting into the right direction. Have you heard about Mealy and Moore's machine?
So,
Mealy machine and Moore's machine?
no, sir.
No, sir.
Please go through that also before we start our next class. It's not that big. Just go through that and try to understand the basic definition of combinational circuits as well as sequential circuits. I will start with that in our next class. It's already 1:35. I would like to end the class right away. and then start with the basic features of 8085. Before that, I would like to know about combinational circuits, sequential circuits, and your Mealy and Moore's machine. So you should have certain basic knowledge of what exactly is all these things. And how many of you are having, so from which book did you read about digital electronics or digital logic?
Sir, how many what?
Which book did you refer for your digital electronics course?
So we had Morris Mano and Tobin
Morris
Schillingford.
Mano, if all of you are having Morris Mano, you would find these answers within half an hour. You just need to recall this. I think this is a part and parcel of your course. This understanding these basics becomes a prerequisite for you to move further. It's as simple as that. So let's start. I think let me close this session. I also need to tell you about the marks distribution. I will be telling you about the marks distribution. I will be talking about this, initial features, and so on. To see you in the next class. Thank you, and I want the list of students who were present for today's session and who have enrolled for this class. So who would be giving it to me?
Sir, I have already sent the list of students' names who have enrolled for this class.
No, but then as I understand, we have also requested for change in time for the coming Friday class, as well as I think there are 3 more extra days which have been provided to you students to enroll yourself. So let us see how it turns out. I think it's up to 4th of September, right?
Yes, sir.
Yeah, so I would like to have the final list.
Okay, sir.
And if you have any questions or queries, you can always ask me, but I would also ask you to brush up some of your, not everything, but at least the basics of your previous courses that you have done, which probably becomes the prerequisite for you to move further. It's very, very urgent and important. Any questions? Any questions?
No, sir. No.
Kunal?
No, sir.
So this is something which, you know, you're not, sometimes I as an instructor, I'm not very sure how many of you are actually present there, or you're on, but you know, still not in a very interactive mode. So this way, I think having a class interaction is always better, because you have a blackboard, you have a physical presence, as well as you know who all are, you know, in the class. This is like you can also switch on, and then you can roam around and come back and then sit back again whenever I call. So be a bit more attentive and try to brush up few things which are prerequisite for you to go further in this course, and that is also essentially otherwise. I mean, like if somebody asks you what exactly is what, and if you are not able to tell, we're talking about Boolean algebra. Why do we use Boolean algebra? I did mention just now. Yeah, Tarun. Why do we use? What's the purpose of using Boolean algebra?
It helps in solving the problems related to digital logics.
Problem? What problem? Problem कहाँ आ गई इसमें?
Sir,
what problem?
इसी पे digital logics based पूरा. True and false.
Why are we?
Sir, the machine understands only binary, so Boolean logic is the logic behind it.
So we can boil down tasks like, say, subtraction all the way down to binary digits and implement them in a circuit
Okay, I give you
via
homework
Boolean
right
logic.
away. I give you a homework right away. Yeah, Ishan, you were saying something, so you give me any Boolean expression.
Yes, sir. So Boolean logic is simply to.
For the class, just give me any Boolean expression, a big, long Boolean expression, all for all of you. Can you do that, Ishan, or let me do it for you?
So was the question to me? I'm sorry, I missed it.
I
Just A plus A.
Huh?
A plus B. Sorry, I mean A plus B.
A plus B. So this is very simple. Let's talk about a nice Boolean expression. Y, or all of you, please note down Y is equal to A B bar C. Please note down, all of you. Can I start?
Yes, sir. Yes, sir.
Y is equal to ABC plus A bar B C plus A bar B bar C plus AB E plus BC D bar plus CE D bar. So this is a Boolean expression. So it is made up of what? Gates, either in the SOP form or POS form, right? Yes or no? Yes or no?
Yes, sir.
Yes, sir.
So have you got the question? You need. So why do we need to solve this?
So to
First of
minimize
all,
the number of components we use to simplify the circuit.
First of all, try to solve this.
Okay.
I think Ishan, have you got the question?
Yes, sir.
So you just spread it among your. Let everybody solve this question, and then see the difference in terms of number of gates that is used before you solve it and after you solve it, and number of transistors before you solve it and after you solve it. Because the output for this expression before you solve it and after you solve it would be the same. But number of gates would definitely change. So all of you, this is your homework. Class, are you there?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
I've given you a big expression. So you see how many gates are before you solve it, after you solve it, and how many transistors you need to get the same output. The output will always be the same for this Boolean expression. So this Boolean expression you can actually implement using the types of gate we already know. Correct? Yes or no?
So initially we needed six 3-pin
Not now.
multiplier.
This is your homework.
Okay.
This is your homework for all of you. You can pose the expression on your, on your, which on your WhatsApp group or whatever. This is a homework for everyone, not Ishan, not Manasa, not Anmol, this is, or Tarun or Badal. This is for everyone. In fact, you can use another expression, Boolean expression. Try to solve it, see how many gates you use initially, how many you were able to miniaturize or reduce, and then see how many transistors that you're using for your Boolean expression. Boolean expression is ultimately you are expressing your gates, which are made up of transistors for a particular thing, into a expression which constitutes lesser number of gates and transistors, but giving you the same output. Is not just a simple expression. That's a real-time circuit constituting, or a IC constituting a different gates, but having a particular output. Is that clear or not?
Yes, sir.
Sir.
Okay, thank you. Thank you.